Be able to find the effluent. Does anybody know what effluent is?
No.
Okay, somebody look it up real quick. Tell me what effluent
The
is.
place where it's best.
Nope.
Oh.
Not affluent.
Oh.
Effluent.
Oh, like with an E?
Yes.
Okay.
Okay. Effluent. It's one of the things that's on your rubric. We're waiting for Jared, I guess.
Getting there. Liquid waste or sewage discharged into a river or sea.
Okay, waste or something that's put into something else. Okay, so at each location, we have to figure out how much effluent they're putting into the river. So we have to figure out the factory, the drain, and the oil refinery. We have to figure out how much stuff they're putting into the river. Okay, we got to know each one. Okay, and so to know that, we have to know how much water is there before they put stuff in and how much water is there after they put stuff in, right? So we have to know how much volume there is in the river, and we have to know the volume flow rate. Okay, so we're going to talk about volume flow rate. You have figured out the area, right? Figured out the area at each location, and on your map, you also have information about the current. Right, so it says the location and it tells you the current at each of the locations. It's on the assignment choice and that's all there. Okay, and so we're going to look at this. So in physics and science, there's lots of laws of conservation, right? So nothing is created or destroyed, right? So the same thing is true if we have a closed system in water. Okay, so if we have a particular area and a particular speed, if nothing is added or taken away from that, we're going to be able to determine what the area and the speed should be somewhere else. Does that make sense? Okay, so if we're given the area and the flow rate, V is velocity. Okay, and let's just make this easy for us. Let's say this is in meters per second, and this, what would area be if we're using meters? Meters squared. Okay, so each of these are going to be. Okay, so let's take a look at this. If we have a low area and a certain velocity, and those are somehow going to calculate into our flow rate, but we have a bigger area, how should our velocity compare up here?
Slow.
It should be slower, right? And that's our relationship between the conservation of mass that we can determine. Okay, so let's look at this. If we have if we have an area, what do we need to get a volume?
A squared plus b squared equals c squared. No.
Not that one.
Pi r squared.
That is a circle, yes. Okay, so if we have an area, let's say I'm finding the area of
Length times width times height.
right. Okay. So if I have this, and I know the area of the bottom, what do I need to do to figure out the volume of the whole thing? I've got length times width, I need to know this, right? Okay, how is that similar to what we're doing with our river?
We have
Figure out the depth.
We know the depth, right? Your rivers look like something like this, and you've calculated the area of the river at each location.
so we need the width.
So we need to know how far we're talking down the river, right? Okay, so we are going to use a similar thing of the volume that comes by at any time. Okay, so that's what volume flow rate is. It's the volume of water that passes by a location in a certain amount of time.
That's the what?
The volume flow rate.
But I got a question.
Yes.
Some parts of the river flow faster than other parts.
Yes. True.
So, that's going to change up the whole thing, isn't it?
So let's think about that. That goes to the conservation of mass. Okay, so if we have a skinny river, it's going to be going very fast. What would happen if we widened out that river? It's going to go slow. So if we don't have any effluent, if we're not putting anything into our river, the speed would tell us that it's going to be wider. it goes slower, it's going to be wider, and if we take that same river and make it smaller, it's going to go faster. Just like, go ahead.
No, keep going.
Just like a garden hose, right? You turn your hose on, and it's just running out of your hose, it's going pretty slow. You put your thumb over part of that, what happens? It's going to shoot faster, right? So we've taken a big area that's going slow, we've now made that area smaller, and the water has to go faster. Okay, same thing is true with your rivers. Okay, the one thing that's slightly different is we are putting in some stuff into the river, right? Putting some effluent in there. How can we use that?
It's going to change the volume.
It's going to change the volume, right? And so if we were putting nothing into the river, how would what happens here be similar to what happens there? The volume flow rate would be identical, okay? Or the overall volume flow rate would be the same. But if this one's different than this one, what do we know? We've added something to it. You can walk by it. Okay? So that's how we're going to use this, is we're going to look at what is in the river before we start, and then we should say, okay, at location. So we have, remember our river, if we look at our area, we've got,
Okay, so you're going to give us the sections, right?
we're going to, yeah, you have them already. You've calculated the area at each location, right?
But that's not giving us a specific distance.
And you've got the volume flow rate, the current.
Oh.
So you've got the velocity here. So we have all the information we need to do this already provided. The units are a little bit off, and we'll talk about how we get those units the way we want them to. Okay, so we have location 1, and we have location 2, and right before that is the oil refinery. Okay, so we can think of this as our area 1. We can think of this as our area 2. Okay, so if the oil refinery was adding nothing, what could we be saying? What could we say?
Same volume.
Should have the same volume flow rate at both locations, right? If the oil refinery is adding something, then we would see that the volume flow rate is different. Okay? Same thing is true if we go to the factory and location 3.
So is location 1 kind of like the control?
We have to have what the river's like before we start, right? Okay, and so we have L1 to L2, we can tell the difference. But then we know what L2 is, we can tell if the factory's added anything, if it changes from L2 to L3. Does that make sense? And the same thing is true from L3 to L4. Here we have the storm drain. Okay, does that make sense how we're going to use this? Okay, so what we're going to do is we need to calculate a volume flow rate. Okay, so if we look at that, we're going to have a volume flow rate. Okay, so what type of units would we have if we're going to be looking at these units that we have here? Right, so volume would be a meters cubed. In a specific amount of time. So we're going to end up with meters cubed per second. Okay, we know that's going to be the units that we'll have if we're using these units. Just so you know, your rubric asks for gallons per minute, I think, is what it asks for. Is that a gallons per minute or gallons per hour? I think it's gallons per minute. Okay, so which would be the meters cubed in that gallons per minute? Gallons, right? So we're going to have to do some conversions, but that's fine. I'm actually going to walk you through how to do those conversions. Okay? And we are going to have our seconds would all obviously be minutes in that case. So if we need this, and we have an area and a volume, what math are we going to do? We have a meter squared and a meters per second. How do we get meters cubed per second? Multiplication, right? So if we take meters squared times meters per second, we would get the meters cubed, okay? Or our area times our velocity, okay? So let's take a look at a quick example. Okay, so let's say we have our river has a cross-sectional area of 400 meters per second. 400 meters squared. So our area here is 400 meters squared, and it's moving at 0.5 meters per second. Okay. Farther down the river, our river is going to moving at 1.0 meters per second. Okay, and we want to figure out. This is how we can use the law of conservation. We can figure out what the area should be down here based on what we have of our information. Okay, so what's going to be our volume flow rate up here? Our area times our volume, so 400 meters squared times 0.5 meters per second is going to give us 200 meters cubed per second. Okay, are we clear on that? Okay, how can we then figure out what the area is here? It should be, the volume flow rate should be the same, right? So we're going to have 200 meters cubed per second equals, it should be our area times our velocity. And we know our velocity is 1.0. So we're going to divide both sides by 1. So the area at location 2 should be 200 meters squared. Okay, if we look at it and it's 210 meters squared, and we know whatever factory is right here is dumping 10 meters squared of water. Well, if we know that it should be 200 meters squared, but we find out it's 210 meters squared,
Okay.
then we know that they're adding 10.
So you just, okay.
Okay, and that's exactly what you'll do. You'll figure out what it is at location 1, you'll see what it should be at location 2, and then you'll see what it actually is at location 2, and whatever the difference is tells you how much the oil refinery is at. Okay, we're good? Any questions I need to go over again? Okay, we are going to look at the unit changes.
Are we all supposed to have the same? We're all supposed to have the same.
You all have the exact same data. So how could that help you?
Ask three.
Probably check if
You
we
could
have
probably
the
check.
same area.
I actually have the answers too if you want to check. So you can come and see.
After we ask three.
All right, so we're going to look at the conversions that you need real quick. I'm going to do a quick review of how to do unit conversions just for you.
Shanks, I'm sorry to interrupt you, but where are your coffee filters?
You're out? You've used all the ones that are over
There's
there?
none over there, and there wasn't any more cups. Like,
Okay, run downstairs and grab some from Donna then. If they're all gone, then they've all been used. Okay, so what are the units that you have on the river areas right now? Remember we went out 25 feet and we went down feet. So right now your area is in feet squared. And we're trying to get into gallons per minute. Okay, this is where we're going to end up, gallons per minute. Okay, so, and your river velocity is in miles per hour. Okay? I don't hate you. Is in miles per hour. Okay? What would be the easiest way, do you think, to do this? What are some ways that we can get moving? Okay, so before we had...
Wait,
Yes.
well, we need to decide how many cubic feet of water are we getting.
Yep. But it's difficult to convert gallons in meters per hour. So remember though, we did meters per second times meters squared, and that allowed these units to apply to each other.
But they're similar units, so.
We can, but it's gonna, my recommendation would be if we go to something that's easy and then go to gallons per hour, it's going to be easier. Instead of trying to
That's what
do,
I'm saying, that one's easy because they're similar
right.
units. How do we
Instead of
get
trying to do feet per
feet
second
and
times
miles per hour to be similar units?
miles can also go to
5,280.
meters, right? Okay? And feet squared could also go to meters. Right? We could also do,
Miles to feet.
or we could do miles to feet, because we can go from cubic feet to gallons. Right? Okay, so we want to do feet. So what we're going to need to do is we're going to convert
Because I know
this.
how many feet per mile, and I don't know how many meters.
So miles per hour, we need to convert to feet per hour. Correct? Okay. So,
Is this video gonna be somewhere?
yeah, I'm going to record it, put it on YouTube. So we need miles. So let's start with our, you've all done unit conversions before, correct? Yes? Benny? Okay. All right, so we're going to take miles per hour, and we want to go to feet. I'm going to change this to an I so we can distinguish it from meters. Okay? Miles per hour. We need to figure out how many miles are in how many feet are in a mile, right? Anybody know that?
5,280.
So 1 mile is 5,280 feet. Okay? We also want to get to minutes, right? Okay, so how many minutes in an hour? 1 hour is 60 minutes. Okay, and that should be what we need to do. Okay, so we're going to take 5,280 divided by 60.
Why? Oh, never mind.
Multiply everything across, divide by everything on the bottom. Does that make sense? So, so 1 mile per hour is equal to how many feet per minute?
88.
88 feet per
Mr. Jinx,
minute. Yes.
do you have like an exacto there?
Yes, in the physics closet on the side, there's a little basket that's got exact amounts in it. Okay? Does that make sense?
Yes.
Okay, so now we can get our volume flow rate, right? Because we have an area.
So wait, quick question.
Yes.
We can use this. Like this is,
Sure.
we aren't gonna have to redo this. Okay.
It's there.
Mr. Jinx, where's the sand?
Underneath the water on that
How
far
much
side,
do you use?
about that much in the bottom of the cup.
Where's the cup?
I said to grab one off the back that's been used and then rinse it out, and then you can use that. Okay, so you have things like 1 mile per hour, 1.1 mile per hour, 1.07 miles per hour, 1.715 miles per hour. Okay, and we can convert those 1 mile per hour into feet per minute. Okay, so our next step will be we're going to multiply our area. So feet per second times our feet per minute. That's going to give us feet cubed per minute. Now we need to go to gallons per minute. Okay, so let's say we had 1 foot cubed per minute. What do we need to know to go to gallons per minute?
How many feet cubed are in a gallon?
Yes. You want to Google that? How many cubic feet are in a gallon?
Let me check on that.
Okay, 1 gallon is
It's about 0.134
0.134.
cubic feet.
Okay, so we need to take 1 divided by 0.134.
$7.46268656.
7.46. Okay, gallons per minute. Okay, so 1 cubic foot per minute is equal to 7.46 gallons per minute. Okay, so those are all the conversions that you should need and all of the values that you should need. To be able to do your stuff. Okay?
So wait, don't we have to get it to seconds?
No, it's gallons per minute.
Oh.
I am correct. Okay?
Wait, so what is this for? What is this right here?
Once you find your volume flow rate at each location, and you're probably going to find it in feet squared.
Oh, so instead
Cubic
of
feet
putting
per
1
minute.
in,
Yes, instead of putting 1 in, so here you'll have miles per hour, which is on here. You'll just convert those miles per hour to how many feet per minute. You'll multiply that by your area, which you've already calculated, and that'll give you how many cubic feet per minute, and then you'll convert your cubic feet per minute into gallons per minute.
so on this little table thingy you got here.
That was just our conversion from miles per hour to feet per minute.
So then we'd multiply
we
what we
found.
got by,
Yep, if we had 1.75715 miles per hour, we take 1.715 times 88, and that would tell us how many feet per minute. Okay, make sense? Okay, and I'll help you, but you do now have that information. Share that with your team so they understand some of it. I'll post this video as soon as I can. Okay, that's it.
yeah,